All right, so we have some short notes for you today. Today's lesson is on 9.2, solving quadratic equations by graphing. Reminder, quadratic equation is not linear and it can be written in standard form, ax squared plus bx plus c. All right, so how do we solve by graphing? First step, we're going to write it in standard form. And then we're actually going to use graphing calc to do step 2. So if you haven't checked out the graphing calc directions yet, they were attached to the 8.3 assignment. I'll reattach them to the 9.2 assignment. All right, so then we graph it using graphing calc. Look at the x-axis, find the x-intercepts, and the solutions are the x-intercepts. So just some helpful hints for graphing if we want to check. Reminder, the axis of symmetry was at x equals negative b over 2a. And the y-intercept was c. All right, so example 1, a function that has two real solutions. So far we have the equation x squared plus 2x equals 3. Step 1 to solving by graphing is to write that in standard form. So I'm going to write x squared plus 2x minus 3, subtract 3 from both sides, equals 0. And then I already typed this into graphing calc, but reminder to go to the y equals screen, and then you're going to type y equals x squared plus 2x minus 3. Then go to the graph screen, and you should get something like this image that's inserted into the note page. Step 2, we can just look at that graph to see where the x-intercepts are. So it crosses the x-axis at x equals negative 3 and at x equals 1. Those are my solutions. And I can check my work by plugging those numbers into the function and making sure that it equals 0. So let's check the first one. I have negative 3 squared plus 2 times negative 3 minus 3, which negative 3 squared is 9. 2 times negative 3 is negative 6. 9 minus 6 minus 3 does indeed equal 0. So first one's good. Plug in the second one. I have 1 squared plus 2 times 1 minus 3, which equals 1 plus 2 minus 3, which does equal 0. Both solutions are good. All right, example 2 is going to have one real solution. First step is to write our equation in standard form. So I'm going to change x squared minus 8x equals negative 16 by adding 16 to both sides. And now I have x squared minus 8x plus 16 equals 0. Type that into graphing calc by saying y equals x squared minus 8x plus 16. And then if you go to the graph screen, you'll get a function like this one in the image I inserted. Notice it only hits the x-axis once, and that is at x equals 4. So we have one solution, it's at x equals 4. I'm going to check that solution. 4 squared minus 8 times 4 plus 16, which equals 16 minus 32 plus 16, which does equal 0. My solution is good. All right, and my last example is going to have no real solutions. How this is going to look when it's graphed is it's not going to reach the x-axis. So let's rewrite our equation in standard form. I'm actually going to add x squared to both sides so that everything can stay positive. So I have x squared plus 2x plus 4 equals 0. All right, so enter that into graphing calc by saying y equals x squared plus 2x plus 4. And once you see your graph screen, you will see that x does not reach, or the vertex does not reach the x-axis. It's way down there. So if we check it, we don't have a solution to plug in because we're pretty sure it's no solution. So if we're making it equal to 0, how we would solve trinomials before is we would factor it. So I'm just going to check to see if I can factor it. I have x squared plus 2x plus 4. This is a trinomial. I would factor it using magic numbers. Constant up there, middle term down there. This would mean numbers that multiply to 4 and add to 2. Factors of 4 are 1, 4, 2, and 2. None of those pairs add to 2, so we can't factor it, which means we're probably not going to find a way to make that equal to 0. All right, so some summary questions for today's lesson. What does it mean for a quadratic equation to be written in standard form? Well, that's the form ax squared plus bx plus c. How do you graph a quadratic equation to determine its solutions? Well, we're using graph and calc, but then you find where the x-intercepts are. So the x-intercepts are your solutions. And what will the graph of a quadratic equation look like when there are two real solutions? Well, the parabola will cross the x-axis twice. When there is one real solution, the vertex is on the x-axis. And when there are no real solutions, the vertex, the parabola, does not reach the x-axis, so it will never cross the x-axis.